Today we're going to be talking about is Introduction to Projectile Motion. So first off, we got to talk about what is a projectile. A projectile is anything that that is considered a anything that is considered a projectile is when it's only under the influence of gravity, that's the only force it feels after it's been launched. So example, a baseball being thrown, jumping out of an airplane, shooting a cannon. Things that are not projectiles are going to be things that have other forces acting on, like a jet flying. It has that engine, that's another force. The rocket blasting off, that's also a force. And also parachuter, because it has that drag force due to the parachute. These are not considered projectile motion. Now, projectile motion basics is what we call a two-dimensional motion. Something is fired, thrown, shot near Earth's surface is under what is called free fall, under the influence of just gravity. The horizontal velocity is always constant. The vertical velocity is always going to be increasing and accelerating. And then we're going to always assume air resistance is ignored due to simplification. So what do we have to do? Well, we first have to break the vectors into their x and y components. This is your displacements, your velocities, and your accelerations. Each dimension can obey different equations of motion. Horizontal component of velocity. For example, when it comes to the horizontal, its velocity will always maintain be consistent. So the velocity in the x direction, the horizontal direction, will always be the same. It will not accelerate and is not influenced by gravity, because gravity is an up-down force. So the distance it travels in the x direction is influenced only by how fast it's going, its velocity initial, and its time it travels. So we can look at this. As you shoot a cannon, it will fly and it will continue flying. If there was no gravity, this would continue going straight forever. And how far it goes, it depends on how fast it's shot and how long are you measuring it. And this is Newton's first law. An object in motion will continue in its motion unless acted by another force. Now, the vertical component of gravity is going to undergo acceleration. Now, we're going to assume that the velocity in the up-down direction is negligible. You're not throwing it down. Usually you throw it horizontal. And this point, we can just get rid of this part and this part, your initial velocity in the y direction. But then the distance is going to be 1/2 times g t squared. This g is either is the acceleration due to gravity, is either negative 9.8 or 32 feet per second squared. If you want to know how fast it's falling, it is gravity times time. So it's 9.8 times the time, or 32 feet times the time, depending on if you're measuring in feet or if you're measuring in meters. So in this one, if you drop a cannonball straight down, it will accelerate. It's going to start off slow and it's going to get faster and faster and faster and faster until it hits the ground at its fastest speed. Okay, this is Newton's second law because you're being pulled down by Earth's gravity. Now we can combine this one and these and we get the actual true path of travel. And this is the path it travels. It travels what is called a parabola, or that's your quadratic, that's your x squared function in math class. Now, here's the thing. Time is the key. When we determine these, what we're going to do is we're going to determine the time. Time is independent of the x or y equations. So if you find the time, it will be the same for both situations, the x or the y. So you can use the time as that key in finding the vertical y or the horizontal x dimensions. So let's go with our gravity lesson. Ready? Practice problem. At what velocity did the cannon shoot a projectile if it shot it from a 12-meter cliff and it hit the ground 600 meters away? Well, here are our equations, and I would suggest you writing these down if you haven't done so. All right, I want you to figure this out. Remember, time is the key. All right, so first off, we have to figure out, what do we not know? Well, we want to know is how far We know that it's 600 feet away, and we want to know its velocity being shot out at. So that's right here, this velocity. But we know it's 600 meters away, and we know we want its velocity, but we don't know time. So we're going to use one of these other two equations to find the time. And we're going to use this one because we know how tall the mountain, this cliff is. So we can use the distance in the y direction, how tall the cliff is equal to 1/2 gt squared. And we know it's 12 is equal to the 1/2 times 9.8 t squared, where you rearrange that. So 2 times 12 is going to be 24 divided by 9.8, and that gives me 2.45 seconds. Remember that we have to square root this whole thing because of that square right there. Now we can then take that time is the same time as over here, this time. So then we can use this equation now. So we know the distance is 600. Its velocity initial is what we're looking for, and we know it traveled for 2.45 seconds. So we plug that in, and we get 600 over 2.45 seconds, and that gives us 245 meters per second, or 548 miles per hour if you want to put that in miles per hour. So, at what velocity did the cannonball hit the ground at? And at what angle? Well, again, we use the same equations, but this time it's a little bit, we have our time now. And so the velocity final in the y direction is just g times t. And so we take 9.8 times 2.5. That gives us our velocity in the y component is 24 meters per second. But what was its velocity in the x direction? Well, it never changed. Remember, the velocity never changes. It is the 245 meters per second. But we have to add that combined because we want to know what the combined is. So we're going to find this red. This becomes a vector component. So we now have this, and so we're going to use Pythagorean's theorem, where we take 245 meters squared plus 24 meters squared equals c squared. We can also do this with the angle and find out the angle it hits using the tangent function, where the angle is the tangent inverse of 24 over 245, or 5.6 degrees from the horizontal. And again, we use our velocity in the x direction, and then square that, plus our add that to our 24 in the y direction, square that, and then square root the whole thing, and that comes out as 246.1 meters per second. Notice that's a slightly different answer from our previous problem, which was 245, because we are adding ever so slightly some of that y distance, that speed here, this y speed is speeding it up ever so slightly, so we get a little bit more extra speed when it hits the ground. So what you guys are going to do is this. It's called shooting for your grade. You're going to make a machine that shoots a ball a certain distance, and you're going to shoot a machine that shoots it horizontally and calculating its velocity and then figuring out some problem on there. Now, if you shoot at an angle, we're not going to deal with this, but in AP Physics, you will. But the way you do that is you have to get your x and y components using the trigonometry that we've already done, breaking it into its components, and then you can add those together. Now, this projectile is then launched at an angle, and it rises to a peak before falling back down. The trajectory of such a projectile is called a parabola, and the range is the full length of that arc, from where it takes off to where it hits. The maximum height is where it hits the top of the curve, and the acceleration at every single point is always 9.8 or 32 meters per, or 32 feet per second squared, and the entire trajectory. It does not matter, even at the tip of its thing, it is still accelerating at 9.8. The velocity is then tangent to the path of the entire trajectory, and the velocity here is actually 0 at the tip. So the velocity here, you can look at it and we can break it down. No matter what, it always has an x component and will never change, but the y has a bigger y, slows down, and then turns around and then comes back down bigger, bigger. Notice how the entire vertical velocity changes while the horizontal velocity remains constant. Where is there no vertical velocity? Well, it's at the top. Where is it at its max velocity? Well, that's at the end or the beginning, depending on which direction you look. So its launch and landing is symmetrical. So the angle here will be the angle there, and the time itself will also is also that the time is also equal at the pinnacle. So the time it takes to get up will be equal to time down, of course, neglecting air resistance. Oh yeah, here we go. Time is the flight is the same. So it's just time is the halved. So if we can find this, the time is halved. All right, key factors here. Horizontal. Time of the flight is equal to the drop time. The initial vertical velocity is 0 meters per second. The horizontal velocity never changes. Acceleration is always 9.8 meters per second. The time of the apex is half the total time of its flight. The initial vertical velocity is always velocity times the sine of your angle. The initial horizontal velocity is the velocity of cosine of that angle, and the acceleration is always 0 in the horizontal direction. So, if you have any questions, go ahead and write them down and ask me in class. We will deal with this a lot more when you get to class.